Welcome to Carlton's Math Corner. Today we're going to talk about solving algebraic equations with addition and subtraction. At this time, please make sure that you have your math journal as well as your vocabulary packet. Our target today is I can solve addition equations using inverse operations. Well, let's talk about, first of all, what an inverse operation is. Well, an inverse operation is the opposite operation. So if I start off with addition, the opposite of addition is subtraction. If I start with subtraction, the opposite would be addition. Same is true with multiplication and division. They are opposites of each other as well. So looking at this equation, an equation is kind of like a balancing beam or a balancing scale. You are trying to keep it completely equal, okay? And so one side is always equal to the other side. Or we say the left side is the same as the right side. And so if I look at this, this is actually a representation of an equation. And on the left side, we have 10. And on the right side, we have 3, but we have a secret number. Can you figure out what is the secret number so that both sides are balanced? Now, if you said 7, you are correct. Why would it have to be 7? Why would this have to be 7? Exactly, because if I have 3 already, I need 7 more to make it 10. Now, is there another way to figure out or find our solution? Yeah, what did you do with the 10 and the 3? You subtracted. Now, if I take, okay, so remember I'm trying to keep my beam balanced. Okay, here's where the 7 comes from. If I take away the 3 off this side, if I take it off, completely take it off, that means I need to subtract 3 also on this side. And if I subtract 3 on this side, just like I subtracted a 3 from this side, now I have 10 minus 3 is 7. And so that's my pond. My missing number is equal to 7. Now, since I subtracted on both sides, the reason why I did that is because I'm trying to keep both sides balanced. And that is called a subtraction property of equality. I'm trying to keep both sides equal, so I need to subtract from both sides. Okay? So if I look at this next problem, 7 on this side, and then I have something plus 2. Now in algebra terms, this is what it would look like. 7 is equal, this middle means an equal sign, is equal to some number of variable plus 2. So what is my missing number? Those of you that said 5, you're correct. And the way that we got that is we subtracted 2 on both sides because subtraction is the opposite of addition. It's the inverse operation. And so I'm doing the inverse so that I can get rid of this 2 and take it completely off. I'm trying to get this variable by itself. And if I take away 2 here, I have to take away 2 from this number as well. And so that is where I get my answer of 5, because 7 minus 2 is 5. And so M is equal to 5. Okay, so let's look at some more problems, but let's look at them in more algebra way. Okay, let's look at some problems that actually don't have whole numbers in them because we can still use the same steps. Okay, so here's my equation. And what I like to do actually with equations is, since I don't have a scale, I like to actually put these lines down here, and I call them railroad tracks because they remind me of a railroad track. Okay, and so what I do is I basically put these here, and then I put an equal sign at the bottom. So now I'm trying to figure out what is x, trying to find that. So I'm going to look to see what operation's being done. Well, I see addition. And so what I'm going to do is I'm going to subtract, because subtraction is the inverse, it's the opposite. So, and I'm going to do that on both sides, and I am going to subtract whatever number is next to it. Well, 5.8 is what's next to it. So I'm going to subtract 5.8. So I'm going to take 8.6 minus 5.8. Now, when you're subtracting decimals, the decimals need to be lined up. Okay, that's the most important thing, and this only is true for adding and subtracting decimals. And then after that, I can ignore them. I can just subtract like I would normally subtract whole numbers. I could look at this as 86 minus 58. And if I have 86 minus 58, first of all, I notice that I'm going to have to put 16 minus 8 and borrow one here, because there's no way that I am, 6 is less than 8. So I need to borrow. And so really I have 7 minus 5 and 16 minus 8. So 16 minus 8 is 8. And I'm going to put that to the right of the decimal because I'm lining up the decimal points. And then, and honestly, I could even put a line underneath them so I can say that's, I'm trying to find the difference between them. And 7 minus 2, or 7 minus 5 is 2. So my answer for x is 2.8. Now, is there a way to check your solution? Solution, remember, is the answer. Can you check this and make sure that it works? Let's bring down the 2. Can I check that? Yes. I can actually take this 2.8 and I can put it in here. And I can put it in back in for the missing number. So I can do 2.8 plus 5.8. Do I get to my original 8.6? Yes. It's a check. And I can make myself a little check. It's done. How about this problem? How do I figure out what m is? Well, first of all, I notice addition again. So I'm going to do the opposite. So the opposite is subtraction. So I'm going to do minus, and I'm going to subtract whatever's next to it. So we're going to do 1.6. And then whatever I do on one side, I am going to do on the other side. Now, what I just realized is I have a number here that is 1.3, which is smaller than 1.6. And we have not worked with any negative numbers yet. So I'm going to actually change this number to 1.8. I'm going to make it bigger than 1.6 because I don't want a negative answer. Not saying that you can't do it. I know that you probably could find the answer, but I want to just focus on knowing how to solve an equation. I don't want you to think about negatives right now. Okay, and so we're going to take that. So please change it to 1.8 instead of 1.3. And so we're going to subtract 1.8 minus 1.6 and find an answer for this. And so I'm going to draw railroad tracks again because I want you to see the right side of the equation and the left side of the equation. And then I'm going to draw a line down so that I know that I am solving. Well, 1.6 minus 1.6, that's just 0. And so I really don't even need to acknowledge that anymore. But over here, 1.8 minus 1.6, I lined up the decimal points, and now I just subtract as normal. 18 minus 16, kind of look at it that way to get your answer. But we still need that decimal point. So we drop it down, and we get 2.2. So my answer for m is 0.2. Okay, and we can check that answer by putting 0.2 in for m. Is 0.2 plus 1.6, is that 1.8? Yes, it is. Nice job. How about if we had fractions? So look at these two problems. If I am working with fractions, Same thing. If I see addition, I subtract. So I'm going to take 7/8 and I am going to subtract 5/8 from it because I want to subtract whatever number is next to that addition sign. And so here's my line straight down, and I'm going to subtract 5/8 on both sides so that I keep my equation balanced. Okay, so what is 7/8 minus 5/8? Well, my denominators are already the same, and so I can just subtract. So I can subtract my numerators. 7 minus 5, 7 minus 5 is 2. So I would get 2/8. Now my question to you is 2/8, is that in simplest form? Because remember with fractions, we have always put them in simplest form. So is 2/8 in simplest form, or can we rewrite that? We can actually rewrite that. What can you divide 2/8 by? Yeah, we can divide them both by 2. So what is this the same as? It is the same as 1/4. You're absolutely right, and that's my solution. Okay, is 2/8 plus 5/8 the same as 7/8? It is, it's equal to it. So we can check our answer. Okay, look at this problem. The opposite operation, again, of addition is subtraction. So let's subtract. If I take and draw my lines, first of all, notice I am subtracting the number next to it. So that's 8/11. So I'm taking minus 8/11. And if I subtract 8/11 on this side, what do I have to do on the other side? Exactly. I need to actually put minus 8/11 on the other side. Now this one's a little different because up on top here they have the same denominator. Down here though, do they have the same denominator? No, they don't. And so we actually need a common denominator though when you're doing subtraction. So I'm going to actually rewrite 3/4 over on this side. I'm going to write 3/4 and 8/11. And I want you to tell me what's a common denominator between the two, between the 4 and the 11. What would be a common denominator? Okay, because remember Fix-It Felix, he comes in and fixes them. They need to be fixed. Well, if you multiply them, 4 times 11, you actually get a common denominator of 44. So why don't we make their common denominators 44? And how do I get from 4 to 44? Well, I multiply by 11. So how do I go? So I have to do 3 times 11. So I get 33. Nice job. So I have 33/44. And then over here, how do you go from 11 to 44? Times 4. So let's do times 4. So I get 32 and 32/44. Now can I subtract these? 33/44 minus 32/44. So I get 33 minus 32 is 1. And then the 44/44, those stay the same. The 44 stay the same. And so let me get rid of this underlining part. So my answer for M is equal to 1/44. At this time, what I would like you to do is do the following 2 problems for tomorrow. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.